I will now demonstrate the reverse integration function to analyse a depth jump. First, I will open a previously recorded trial of a depth jump. If we look at the force, you will see that the athlete begins off the force plate, standing on a bench to the side of the plate. They drop down and land and jump. This is takeoff, then they land again, and then they stand up. And this is their body weight. So the first thing we'll do is actually determine the mass of the athlete. So we'll put our set point 1 and set point 2 on this nice flat area here and set the mass. If we then look at the velocity data, however, we'll see that it's unusable. And the reason why is the system doesn't have knowledge of what's going on before the athlete lands on the plate, when they're standing off the plate. To overcome this, we can actually integrate the force signal in the opposite direction. With most systems and processes, the force signal is integrated from left to right, and the integration produces the velocity data. But because we have no knowledge of what's going on prior to the athlete landing, this is not possible. So instead, we have this function called reverse integrate, whereby we integrate the force signal from the right to the left. So let's just display the velocity data, and then we'll click on reverse integrate. And now you can see by looking backwards through the data, we can actually generate usable velocity information. We still have the problem though where the velocity is shooting off into space here because the athlete is standing on off the force plate. But we can use the crop function just to zoom in and look at just that area. I'll just check on force to see that I've got everything I want. I'll just move set point 1 back a little bit, and set point 2 I'll move it along a little bit there. I'll now right click on the graph to bring up the graph options and click on crop and close, and now we've just zoomed in, cropped, so that we only have this force data of interest. And if we have a look at the velocity, we've got quite reasonable velocity data. So that's how to use the reverse integrate function to analyse a drop jump, in this case, integrating from right to left to generate usable velocity data.